So now we are talking about star schema. So let's suppose we have this data having two records: customer, product, region, and sales. We already know that this is transactional data, right? Because we have a combination of attributes and measures. Whatever highlighted in yellow color is attributes, and this sales is a measure. So this will give me the information related to my transactions. And in case if I have to store the data within the database. So right now this is in the normal table, right? So when we are storing data in a normal table, this is known as normalization. And this is very important concept to understand. Normalization. So when we are storing data in a normal table, this is called as normalization. What does it mean? It means that when we have to write a new record, so this normalization always write record row wise, and it also read the data row wise. So when we have a table, we will be doing two operations only. Either we will write the data or we will read the data. If we are writing the data, we can only write the data row wise, and if we are reading the data, we can only read the data row wise. Okay, for both the things. So normalization is very fast for writing the data. How I can say? I will prove that. So whenever you have to go with any new entry, what you will do? You just create a new entry. That's it. You are creating for new entry. Okay. So new entry created. So whenever you have to create a new entry, you will simply write the data row wise. Okay. Now imagine if I want to find out a very simple query, what is the total value of sales for C1? Sales for C1 customer. So this is the total sales for C1 customer. Okay. Now imagine this table right now is having three entries. This table might have more entries. Imagine this table is now having 1 million entry. And if I have to just again find out what is the total value for customer C1, total sales value for customer C1, right? So right now we can see this is on the first row, but because this 1 million entry, so this C1 can exist anywhere within this table. The C1 can exist even in the last row. So C1 can exist within middle or anywhere, right? So what we have to do, because we are writing the data row wise, so we have to read the data row wise also in this normalized structure, in this normal table. So imagine if I'm reading the data row wise, what will be my challenges? My first challenge is I have to read row wise. It means I have to read all the records, because we have to go row by row, right? We have to read all the records. It means if it is having 1 million record, and if I am having only one record which is in the beginning itself, but still that it will read this entire row, entire record, because C1 can present at the last also, C1 can present in between also, anywhere. But the reality is the C1 is existing in only one row is available in this table for C1. Still I am reading this entire 1 million record, right? Tomorrow this turned into 1 billion record table. Just with this simple query, I have to read this 1 billion record. So what will happen? I will let, this is not an optimal way. And you know that our entire hardware and software work differently. It work on the basis of 0 and 1. Our hardware and software does not understand anything like A, B, C, any alphabet. So when you are reading or writing the data, it converts into binary first. This is very complex. I'm not going into that much complexity, but we can understand in this manner. We have something known as input output operations. And why this input output operation is going? Because if you have to write any data, let's suppose if you are writing data like A for apple, right? So it will go with ASCII value. So actually system does not understand A. System understand, okay, A stands for 65. So 65 will be converted into binaries, like in the form of 0 and 1. Okay. If you want to see, I can do it for you. Uh, so 1, 2, 3, 0, 1, 2, 3, 4, 5. So if you convert 65, this will become your binary. Okay. Similarly for B, it is 66. So similarly for C, it is 67. So you can think of, if it is trying to convert every single record, it will be hang. The system will be hang. That's the reason if you want to make this data read, it is very difficult to read in a normal table. So that's why for normalization, it will become write optimized, but it is not read optimized. The meaning of write optimized means easy to read, but it cannot be read optimized. It is easy to write, sorry, my mistake. So write optimized means easy to write. So if we are storing data in a normal table form, it will be write optimized because it can writing the data row wise, so there is no problem. But when you are reading the data, this solution will not work. And why solution will not work? Because of two reasons. Reason number one, it will convert your alphabets and every string into 0 and 1 form, right? In number form. Okay, so that's the reason. Okay, so because of input output operation. And second reason of delay is because we are reading the data row wise. Correct. Now if you have to solve this problem, how to do that? Okay, what we can do, this is normalization, means we are storing data in normal table form. Correct. Now what we will do, we will not store this data in normal table form this time. For example, if you have to store this data, okay, instead of storing simply in a normal table form, what I will do, for customer I will create a separate table. Okay, for product I will create a separate table. For region I will create a separate table. It means I am breaking the table. I'm breaking the table, and this breaking of the table is known as denormalization. Okay, so this is known as denormalization, but I should not break it simply. What I should do, okay, so I have broken this table, and I have broken this table based on attributes and measures, because we listed down there are two problems. Problem number one was input output operation, because everything was an alphabet, so it has to first convert into in the form of 0 and 1, right? So if I make these entries deleted from here, so instead of this C1, if I store this C1 here, okay, and against this C1, if I generate some number like 101, okay, so this will become my customer, this will become my dimension IDs, dim IDs, you can think of. And in place of this C1, if I copy this dim ID and paste it here, similarly for P1, right? I just save this product here in this table. This is master data table or dimension table. We can come later. Okay. But I am going to store this name of the product here, and in place of this, I am going to generate 111. This is the dimension ID for product, and I can save this product here. This is dim ID underscore product, something like that. P. or let's say I'm going to use dim id underscore c. Okay, now in place of this, okay, now coming to region, I don't know. Okay, sorry. So I have just selected the region, and I'm again creating a dim id for region. This is dim id underscore r, and I'm this time I'm converting like 1. Okay, simple. Okay, so your first problem is solved. Why? Because you converted all your alphabets into number. Now input output processing will be fast, right? Because the system understand the 0 and 1, so we can easily convert these IDs into 0 and 1 without any problem, without any further steps. So this again the same thing, you can make it fast, you can make it C2, and you can make it like 102. Okay, and you can make it like P2, and we can make it like 222. Okay, and we can make it like BL, you can make it like 2. Correct. So if you want to delete it, just you can make it like 102, then you can make it like this and this, right? Okay, now see, what does it mean? It means this is known as fact table. Why this is known as fact table? Because this contain all numerical values, facts and figures. If you have heard in your English, right, people are used to talk about, we should believe on facts and figures. So facts are numerical values, figures are numerical values, right? So these are the numerical values, that's why it is known as fact table. This is your master data and contain your dim IDs, that's why it is known as dimension table. The dimension table is basically the table which only contain your dimensions. Okay, and I can tell you what is the significance of having the data stored in this manner. Okay, so your dimension table and fact table is connected with the help of dim IDs. So you can see, you know logically both are connected. Okay, if you see, these are the dim IDs, it is connected. Okay, you can see this fact table and dimension table is connected with the help of dim IDs. Okay, fine. This is your region dim ID. Okay, so this create something known as structure like a star. That's why it is known as star schema. Star schema. What is so star schema is based on denormalization. So denormalization means you are storing data in normal table. Denormalization means you are breaking up those table and store data in a cluster. For example, you have stored master data for customers separately. You have stored product data for customers separately. You have stored region data for customers, this transactional data separately. And now you have generated these dimension IDs. Okay. And instead of storing it here, you have stored here. This is known as star schema. Okay, and the best thing is that you have resolved both the problems. So here you have listed two problems: input output operation and reading row wise. Now let's see, one problem is resolved. Is it reading row wise now, or is it reading column wise? So again, I will try to find out what is the total sales for customer C1, right? So how I can do that? So for customer C1, what is the dimension ID? 101. So in master data, we know if we have to find out for customer C1, I will have to go in this table, and instead of reading every row, I will filter this entire table with 101, and that will be easy because it's numerical, right? So it is not reading row wise, but it is reading column wise, because first it will only go and check this column. That's it. So that's why it is reading column wise. So it become read optimized. How it become? It become read optimized. Read optimized means easy to read. So this is the concept of our star schema. And when we are loading the data, when we are creating any data stuff for reporting purpose, right? Reporting purpose or analytics purpose, we used to follow this star schema. This is further known as extended star schema. Okay. And we have another layer created, which is known as surrogate layer. Okay. So if you want to just understand the concept of extended star schema, okay, uh, let me imagine this is the region. Now I have created one more table, okay, for region, which is known as surrogate table. Surrogate table. We have heard about surrogacy. Okay. So if a mother is carrying baby of someone else, this is known as surrogacy. The same thing, right? This is not the actual mother. She's carrying the data of this one, right? So what will happen? She will carry the data, and against this data she will create another SID. This is known as SID, surrogate ID. SID underscore R, surrogate ID for region, and this is region, right? And instead of this, it will store the SIDs, right? So now a new definition has arisen. Fact table is surrounded by dimension table. Fact table is surrounded by dimension table. Fact table and dimension table are connected with the help of DIMIDs. Dimension table is further surrounded by surrogate table, and surrogate table and dimension table are connected with the help of SIDs. Okay. So this will become a multi-dimensional modeling. Multi-dimensional modeling. Modeling. How it is useful? Why this? And this is known as extended star schema. So we have extended the star schema to another level. Okay. And why we did that basically? Okay. Let me explain you. Imagine in my data set, I'm having attributes and measures, right? I'm having like 1000. Imagine not 1000 big number. Let's say I'm having 500 attributes. Okay. And how many measures? Let 4 measures. That's it. And out of these 500 attributes, you have some attributes of customer, some attributes of material, some attributes of region, some attributes of country, and so many things. Okay. Account number, jail account, so many, profit center, right? So if I follow this star schema with this data set, what will happen? The fact table will be a one fact table, which will be containing 500 different dimensions and 4 you know things. So it will be very difficult to manage, because one fact table will be surrounded by 500 dimensions. Can you imagine? It will become so difficult, right? So then what we did, we know that out of this 500 dimension, 100 attributes are belongs to customer, another 100 attributes belongs to product, or you can say 400, not 400 but 300 attributes belongs to products only, like product description, product expiry, product so, right, like this. And another 100 meant for region, right? So what I will do, instead of creating these 500 attributes, my structure will remain same. There will be one fact table, there will be 3 tables, 3 dimension table, customer, product, region, and this dimensional table is further further linked with surrogate table, and this surrogate table will be having these 100 columns. Getting a point? these 100 columns. For customer, this surrogate table will be having these 100 columns. For product, it will be 300 columns. So my schema will look simpler, and we can easily trace back the data while reporting. So this concept is very, very important to understand. What is the difference between star schema and extended star schema? Now I'm again giving you a recap. So we have a fact table which will only contain fact. Fact table is surrounded by dimension table, and dimension table is further surrounded by surrogate table. Making sense?
Yes, sir.
Okay. So that's all, and it's very important. And so basically, when we will create our master data, because we will have to create our master data in we have to store our master data for reporting in gold layer, right? So we will follow this architecture. So that's why explaining this is very, very important. Now we will first do we will create our notebook, okay, in gold layer. And listen, this is not only restricted for Databricks or anything. This is a universal concept. When you are doing a data engineering, you have to load the data in these schemas if you have to go for enhanced performance of reporting, correct? Right. So when we will create the gold layer for customer, so customer is my master data, right? So firstly I will do it with the help of SCD type 1. As we already know, SCD type 1 will overwrite the data, it will not preserve the history. But when we are writing the master data, what we will do, we will create this stuff. We will generate the dimension IDs, a unique ID. Got it? We will have to do that. So during our exercise of creating the gold customer notebook, we will introduce two things. We will introduce the override functionality, how to override the master data in case the master data getting changed. But before loading the master data, what I should do, I should create the dimension IDs, dim IDs, right? Dim IDs are unique IDs in form of numbers, right? Similarly, when we load the product master data, what we will do, we will introduce SCD type 2. Okay, the meaning of SCD type 2 is it will not only store the master data, but it will also preserve the history. Okay, so when we have discussed, this will preserve the history in this manner, right? So if any master data is changed today, right, it will keep that master data as it is, but it will create a new row in SCD type 2, right? And it will update the start date and end date. End date will be infinite date, and start date will be today's date, and this new master data is changed. If we are going with SCD type 1, it will simply overwrite the existing data, and it will not preserve the history. It will not store this information, start date and end date, right? So we are going to implement this with the help of this concept. In both the cases, dim ID has to be created, right? And in SCD type 1, we will see the override functionality. In SCD type 2, we will see the preserve history functionality. Okay.